welcome back. Today we are going to understand today Leetcode question, and today we have given this question, swap two nodes in the pairs, right? So this is the question based on the linked list, and we have to swap every two nodes, two adjacent nodes you can say, and we have to return its head. As you can see, we have to swap every two nodes, right, and we have to return its head. So you must solve the problem using you can say without modifying the lists, right, and you have to solve using logical things how to do that, right? So to do that there is many approaches, right? You can follow that, right, in which we will see the first approach we are going to see here is recursive approach, and then we will going to see the another approach, that is iterative approach. Okay, so you can try by your own, right? So you can pause this video and you can try by your own, and then we can go ahead, right? So before that, let's understand the you can say example, what example is saying. So example first is saying that we have given these nodes, right? So we have to every two adjacent node we have to take, right? So for this one, the adjacent node is 2, right? So this will go here and this will go here like this. So as you can see in the resulting one, 2 is coming first, right, and then 1 is coming again. There is another one, that is we have this node and this node. So this should go here and this should go where? Here, and it is coming like this, right, as you can see. So this is the resulting you can say linked list we have, in which we have to return its nodes, and you will see the output like this: 2 1 4 3, and previously it was 1 2 3 4, right, like this. And if you want to see the another part, let me go down. Yeah, another example you can say. So if there is null, we don't have anything, we will return a null. But if you have any element into that, so there is no adjacent, so we will return 1 only, right? So these are the examples we have given, right? And to implement that, let's go to the coding section here, and we'll try to do the coding here. Okay, so before understanding, let me tell you one thing. Okay, so we have this question, right, and to do solve that, right, the problem doesn't ask us to you can say for the entire reversal of the linked list, right? As you can see, this is the first part for this one, this is the second part, you can say. So after each node, right, we have to do what? We have to traverse its adjacent node. We have to save the adjacent node only, not the whole, or you can say entire reversal we have to do, right? That doesn't ask the problem, right? So it rather asking us to swap every two adjacent nodes of the linked list, starting at the very first node, as you can see here, as 1 and then 2. It is moving like that. So what we have, let's suppose we have given this node, right, and we have to do the swapping like this, right? So what we can do here, right? So now the basic thing what we can do is to reach the end of the linked list in the step using 2 recursion, right? So the first recursion what we can do, let's suppose I'm going to write here. Let's suppose we have given that is the first node we have given, and there is another is a point, right? So we know that each node contains its data and its pointer, right? So this is, if this is a data and this is a pointer, right? So this pointer connects to another node, that is we can say like there is 2 as a data and we have another as a point, right? And it will connect to another like 3 we have, and there is another is a pointer. So this going to connect like this, means it will look like this only, right? So the next element is nothing but what? This comes to null. Next pointer we don't have, so this is null, right? As you can see, let's suppose this is original one, right? And if we want to do the swapping thing, right? So let's suppose we are starting from here. So this is nothing but our head, right? So let me change the color so you will understand it will be very good. So you have here the head, you are starting with here, and after the swapping, right, what we have to do actually, so what we are going to do, we have to take a jump from here to here, okay, like this, just for understanding. Okay, and then you can take a jump from here to here, like that, means 2 jump we can do, or either we can take 1 jump from here to here, and then another jump we have to take from the any element that we have, means from here to the next one, like this, right? So this is the better, like we can take like this from here and then we can go to the next one, right? Yeah, this is the best thing, because we have to escape one, okay, yeah, it's better. So what we can do, like we will try to reach the end of the linked list in the step of using two recursion, right? So in the first recursion we'll go from here to here, and then we will go to here, right? While the backtracking, the nodes can be swept. Like how we will do that? So if initially what we have one ham and we have two nodes, right, like this. So this is connected with another one, this one, and this is connected with like this, we have connected with another one. Okay, now we have 3 and 4, right? So what I'll do, I have swept this one like this, okay, and this is going to connect with now 3, and this is nothing but connecting with the null. We have null here, right? So what we are doing here, we are swapping here, right? This part we have swept to here, from here to we have swept to here, right? Like this means here we are doing a backtrack. What we are doing? Backtracking we are doing here, okay? And here what we are doing? We are doing recurse, or recurse, we can say recurse, okay? So we are here, we are doing recursing, right? Means to reach at the end of the linked list, what we will do? First we will do two recursion, and then we will do backtracking to do the swapping, right? The backtracking the nodes that can be swapped, right? So two steps we will do. So in every function we call, right, and we take out two nodes which would be the swap, and the remaining nodes are passed to the next recursive call, right? So the reason we are adopting a recursive approach here is because we have a sublist of original list, right? And that would be still be a linked list, and hence it would be we adapt to our recursive strategy, right? So assuming that the recursion would return the swap remaining element list of the nodes, and we just swap the current two nodes and we will attach the remaining list, we will get the recursion of the two pairs. It means what I'm trying to say here, let's suppose I'm going to write here, okay? So first of all, let's suppose we have two nodes, right? So I'll take one node here like this, and this is connected with another node that we have data 2, and we have this pointer, and this is nothing but what it is connected with. There is a remaining, I'm telling about this your remaining list. So this is a list where we have a list remaining, right? So we will connect with this one, or either if it will be marked like this, so it will look like this. This is the remaining list that we are going to connect this one, okay? Now so this is your original list, right? What is we have? This is your original list, okay? Now what we will do, the original list we are going to swap, right? So every call is responsible for swapping the two nodes. The remaining swap list comes from the next recursion, right? So how we'll do that? Means we will, after swapping this one, this will come here, and the pointer is here, it will point to here, and this is the pointer. Like this will become, and it will look like this one. I'm trying to say this one, okay? And this is connecting with this one, right? Now this is the part we are talking about. So this is the original list we are going to swap, and this will connect with the what? Remaining swap list, like this, right? It is pointing to here like this, or I can point like this, okay, like this. So this is your remaining thing that we have already seen, and this is the pointing thing we have, right? So here what we are doing actually, so for every call, right, what we are doing, we are swapping two nodes, right? And the remaining swap list that is coming from the next recursion, this will come from the next recursion, right? And that way we are going to connect it, right? So like this we will do our you can say swapping with the two current nodes, and we will attach the remaining list, and we will get from the recursion of the two swap pairs each time, right? So what we will do, we will start from the recursion of the head. Let's suppose we are going to the code section, and then we'll try to do, I'll write the code, then you will understand a little bit. So as you know, this is the linked list, we have link node, this is the node we have, node class, and each node class will contain value, and its next as a pointer it will call, and rest of the you can say as a constructor we have. So let me hide this one, okay? So from here what we will do, we are going to see the code, and then we will do the implementation, so we'll understand, okay? So first of all, here what we will do, we'll start the recursion from the head of the node of the original linked list, and to do that what we should do, give me 1 second, we should start first of all, let's check first, right? First we will check what if the list has no node, right, and order of the node has one node left, means that is only one node, as you can see, right? Let's suppose we have the head that we are passing, and if it is null, just for understanding, if this is null, then what we will do, will one more thing we can do, or we can say if head is equal to null and head dot next, so that next time we are not going to call head dot next, right? And this should also null. In both case, what we will do, we'll return here nothing but our head. We are not going to do anything, right? So this is your first call, means we will start recursion with the head of the original node, and then we will do the swapping, right? To find the swapping, what we have to do, we have to find two nodes, right? That node to be swapped, right? To swap two node, right? What we have to do, we have to find the this is the node, right? So we can get the node from here. So let's suppose I'm going to say this is our node 1, right? And this will come from what? A head. Sorry, this is nothing but I will start from the head. Okay, another I will take what, the second node I'll put here, and this is our node 2, and that will come from what? Head dot next, right? If we'll do head dot next, so with two node we have, right? And if head or head dot next is null, we will returning head. We are not doing anything, we will not come to here, right? Now what we should do now, so once our two nodes are there, we have to swap, right? And to swap that, what we have to do, we have to swap the node, right? To swap that, what we have to do, we will do node 1, just for understanding, node 1 dot we'll do next node 1 dot next equal to nothing but our, we already have this function, so we are doing a recursive call, so we have to call this one, and this is nothing but what I will pass, the first will pass the node 2 here. Node 2 will start from where? Head dot next we are calling, right? So if we have node, the second node dot next will store where the we are iterating. So while iterating, we have to take one we have to skip, and to do that, node 2 dot next we will do, and we'll store the node 1 dot next, correct? And on the node 2 dot next, what we will do, like this, what we will do, we'll add what, our node 1, like this. So we have skip 1, right? Now sorry, we have to swap 1, right? That we have done already. Now the head is the second node, right? So now the head is the second node, right? Like this we can say. And to do that, what we have to do, we have to return what? Node 2. That's done. So let's try and run this program. Let's submit. So this is working, right? Now in this way, give me 1 second. And to do that, you can see here, right? We are going each time all the nodes. If we have given a list of n nodes, just for understanding, this is a node, right? So if there are nodes connected with n nodes, right? Just for understanding, if there is n node, means we are traversing all these nodes, right? We are going with all nodes, and that's why the time complexity become O of n in this case, right? And here we are taking two nodes right here, right? So each time what we are doing, we are traversing each time, right? All the nodes. Okay, so once you have all these nodes, right, so the utilization, as you can see here, right, we are going with all the nodes we are storing here, right? So in the recursive stack, we will create one stack, right? So first will come the node 1, then it will call node 2, like this, and it will become a stack, right? So this stack will take what, how many nodes? N nodes. It will come over node dot next node dot next node, total node whatever we have, that will come each time here, all the nodes on this stack, and that's why a space complexity also become O of n. Okay, so this is the thing we have to do. The you can say in the recursive way, we will find our time complexity and space complexity. Okay, and we will do the hands-on. Okay, so if you want the iterative way, please ping me in the comment box, so I will create one iterative way approach, and I will go through all the codes. Okay, thank you guys, thank you for watching this. If you like this video, please hit subscribe this channel, so that you will get more notifications for upcoming videos. Thank you guys, thank you for watching.